Hi everyone, I think we are live. Good morning. Welcome to day 11 of building a production rack system for 10,000 plus docs NASA documents that scales for even more than 85,000 to 100,000 documents. That's the infra we're dealing with. And yeah, so far we've built the entire document document pipeline that is totally run by that's using Dockling hybridly and also open source models, totally open source models, which can run on which can run on one single H100, which can sort of process formulas, tables, diagrams, pictures, and technical diagrams and etc. on a from a what from a document. And documents tend to be very complex. If I were to scroll down in one of the image here, you can see over here, they have a lot of index, they have a lot of formulas, they have a lot of tables, they have a lot of graphs, and you can see the images we have and etc. So this is not your general PDF. Your general chunking wouldn't work. And currently we've completed the entire pipeline in the past few streams. I guess the first day one, two, three, part one, part two, part three was like document processing. We worked on that, we fixed that. And right now we have a bunch of issues, and we are currently working on deploying something like this at scale for 10,000 documents. And how do you handle the infra of making how do you handle the infra of processing 10,000 documents, right? So it takes a few days. You want to run the H100 on we've only got 95 GB of H100 RAM, and we should be able to do a lot of parallel processing, batching, and etc. to run these models. So that's what we're dealing on for the past couple of days. A lot of issues. We rewrote the entire pipeline to be able to separate the GPU service, the CPU service, and then reuse a lot of stuff, remove a lot of inefficient stuff. And we did a ton of work. I have to probably write like a blog post, so you can't probably see all the 11-hour or 7-hour live streams, but what you can see is to read the see the blog posts and sort of try to get a sense of what we were dealing with and what we are actually dealing with. Let me actually check my sound input quickly. Okay, cool, you guys can hear me. All right, yeah. So that is it for that. Now, yesterday I mean, there was a lot of from the past streams. I went offline to work on this a lot, and yeah, I have to share a few updates. But it seems like in the last stream we were struggling to even process one document at scale, and right now we can run 24 parallelly, and all of them have their own version of Dockling, and also is able to properly utilize the GPU through batching. And we were able to bring down a big PDF for a couple of seconds. I think the number should be here, but I'll go through the entire thing. So we are ranging about 71 to 80, 71 to 100 pages. A document might have a lot of pages, right? So the proper thing is we evaluate this by pages. So we're doing about 80 to 100 pages a minute. A given minute we're processing 80 to 100 pages. I think we can still go up because we have 10,000 documents to process, so we need to be able to get to that 150 pages per minute sort of range. That's my goal, but let's see. Alrighty. Let's go ahead and test this out. So yesterday we dealt with a very small issue where I'll just give you some background. Where some, for example, some PDF were actually 150 MB. For example, this was 170 MB, but this only had 37 pages. And we came to a conclusion that this scan was super what do you call it? Super big. It's super high quality. So we wanted to reduce the scale size of it dynamically. And I'll be like, I don't think so. It worked out. It still took the same time. I want to test it one more time. It's the next day. So give me the commands that I want to run, or maybe we'll just run it. Why ask? So yeah, I'll like I know this is quite like, if you were to watch the last recording and come back to this, there is a little bit of miscap. It's because I worked on this offline for a bit, and yeah, I had a bit of issues with constantly working for a few days, and I have the need properly and everything, so have a bit of gastric. So yeah, stomach issues, had to go offline, take some break. I mean, I didn't still take break, just was working on this anyway, but I couldn't stream it. But yeah, I'll go through everything. I'll go through everything in a bit. Just give me some time. We'll just test this and come back. All right, so we've activated the PNV. Let's start the. So I'm going to run this test. dynamic scale, and let's watch this. Watch in 1 second and run this. We have 6 documents. Nothing is started yet. Now go back, activate the VNV. So VNV, you can see everything. Other everything is started. We have the Olama model running. We have the Olama. We have the other. What do you call this? Docking services are running as well. Bin activate, and then we wanna go inside research folder, and we wanna start Celery. Actually, I wanna flush everything. And this would have been failed. It's okay. We'll first start Celery and come back. And we'll start Celery. Concurrency is 6. You can run 6 alone, and we'll start this. And I can see it should automatically start. Okay. I'm gonna go ahead and watch this. I've already done by 1. This is giving us about 72 pages a minute sort of range. That's what we want. We want to bump this up to 150. That's the goal. Or maybe even more if we can. Let's see. Let's give this some time. So the second document is definitely taking some time. You know what? I'm gonna restart all the services. I want to kill Celery. Yep, with everything. We'll also kill coupling services that are running. So all of that, those are killed. We have embedding running. Let the embedding be as it is. Actually, we might need to kill embedding as well. Reddish flushed is okay. It's flushed. We don't have LVM with this. Embeddings. Oops. Model is fine. Keep the model as it is. Should start. Give it a minute. And start the celery worker. Concurrency with 6. Nothing is in Redis, so nothing should start. And not sure the skill changes. Okay, please check. Oh, hmm. Because what we're trying to do is that for a 50 MB PDF, if a PDF is more than 50 MB, we try to downscale it. So the so if it's 170, it'll probably be in the 80 MB range, and then yeah, you get the point. Just split it into a half. In terms of quality, you'll also lose a lot of details in that. You should be careful with that. But processing in point 0.5 for like 172 MB is too much. So you just can't do it. You can't just afford it. It doesn't make sense to afford with the current system that I have. It's only one H100, and I need to get it sorted out in 1 to 2 days. Like all the 10,000 processes in a couple of days. Yeah. Actually make it yeah, we'll actually test it and see first, and then we'll try it. So we'll quit salary, concurrency 6, test this. Yes. So you should be able to see a couple of Volama services, sorry, docking services bump up. We'll watch this. The second one is definitely taking time. Again, I think the scale is not working, but we have to wait and see. It takes a lot of time to wait, so we have to be able to wait a little bit and see. I think it's taken some time for unpacking stuff and etc. I think the recent change has made the processing even worse. Can you please check whether increase? Can you please check on this? Maybe do one thing. Remove any PDF that is large. Just remove any large PDFs, and we'll process the documents one more time and see if scale changes is an issue or not. It has taken on. The second image is only 13 MB, but you can see the time it takes. There is some issue. I think bringing on scale has brought in a bit of issues, and it's basically reducing the amount of parallel work that is actually running. So yeah, because reducing scale loads something, I don't know, we should do research and see, but this is definitely slow. Our previous documents were quite fast, like super fast. 24 documents was like it was done in less than 3 minutes. this. Flush all. So, start it. And we make concurrency 5. And here we submit this reverted. Okay, so we should start here. You can see. So we're gonna run the baseline. Yeah, we just run the baseline. Let's see. Oh, good one. Yeah, I think there's some startup issue. Like, so what I'm gonna do is to completely reset this, all the work back again. Some case issue. You would never know. So yeah, let's see. Let's kill embedding also. Good. GPU is pure and clear. So doing a quick warm up to Olama so it will load the model manually. So VLM is ready with 50 GB. Let's put concurrency 3 and run this. And the terminal. Okay, it's starting. Oh, we should do is to be like, say, the research and scripts. It'll take some time, but we'll start this. Those should have been loaded, and the model should load now. And only 3 concurrent, right? Only 3 models will load for now because that's only needed to load. Watch. Okay, I think there's something wrong. So the thing is, VLM timing yesterday it was quite good. There is no, I'm not able to find the reason why it's not working today. Actually, this could be an issue with Celery. So I don't want to use Celery. I want to directly run a document and check how much time it takes. Like directly run it and check it. I think it's an issue with celery, guys. Because it's taking some time on packing and unpacking stuff. I don't know. I don't know. Something is there for sure. Hmm. Picture processing failed. File name. Okay, I think there was a loop going on here. All right, now I think we can, yeah, we'll find the issue. Please don't search for files. Read the entire code because even a small missing context could lead to a very bad outcome. We can't afford to lose time here. So please, in, ingest and you know check all the context required. Full files. Feel free to launch subagents if necessary. Okay, so I think, yeah, it's working out. It's quite fast. And it is a mere issue with text names being large. Nice. But now again back with 95 pages a minute. Whew. Govind, thank you, Govind. Giving everything and done. We're back again. It's actually better than the original phase. Because it's bugging. What was the fix you made? What was the fix? Good. Please update the phase for documentation and then let's test with the concurrent 6 for once. And if everything is okay, we'll move forward for the next. Update the documentation. Oops, sorry guys, doing some Carnatic practice. Mhm. Oh, hey man, Raghav Bodani, I just saw your message. Hey man, how's it going? Going good. Just read through your Meridian Aerospace docs. Wow, nice, great stuff, bro. That's what we're working on. Day 11, yeah, 11, and we have been working, having a ton of issues in scale, processing 10,000 documents and, plus very complex documents. We're using open source models and we have only one GPU. So we're learning all of this parallelization, all the infra stuff. That's taking a lot of time, but yeah, we're getting there. I just fixed a small issue and I'm gonna test it with a few documents. And yeah, hola, Nathan Corals. Hi. Good to see you. Sam, hey man. Yeah, Sam is actually my teammate. We're working on something called Intraplex, and he's taking care of the sales side, and I'm working on the tech side. And good to have him on the team. Yeah, guys, if you have any questions, feel free to drop them as we go. I'll try my best to answer. And yeah, check you guys, because the thing is, I don't open up the comments very often, and I don't know, for some reason OBS doesn't show me the comments. I'm not able to see unless I click on a video and come back to this. So yeah, sorry about that. All right, so I think we're making some progress, and you can see that we are getting about 16 docs. Actually, not 16, a lot of documents per minute. We can actually, yeah, 16 docs a minute, but even more, we could actually do a little bit more. And we're getting actually close to 100 pages a minute, which is very good. Totally, which open source models and etc. And with very limited amount of compute. So yeah, I want to do a single test for 24. What do you call? I want to do a single test for 24. I guess 6 documents in a given shot and see how long will it take. And yeah, we'll take it from there. Okay, we'll test the 6. Yeah, I think this also includes so that, for example, we also have a lot of issues where one single document, for example, this document would actually be 37 pages, but at the end it'll actually end up they be 170 MB, and you might have 300-page documents that's less than 10 MB and stuff like that because these are scanned copies. And so those issues are definitely there, and that's what we're trying to deal with them. But yeah, let's see the size of the entire size. We only have 5 PDF. That's more than enough, I think. And yeah, these are two very small ones here. We'll test the large one very soon. Um, it's fine. So I'm gonna go ahead and flush for this. Let's start the worker, and I actually want to start it again because concurrency was actually running. And yeah, this is running. We'll create a one batch, a new one. Test 6 workers. Activate this. Go back. Yeah, and this we'll put them. Okay, I've started it, and you can see the process has started. We'll quickly go ahead and watch the progress. Watch it for every second. Oops. Okay, already we have kicked one, and you can see all the GPU stuff happening, going through over here. I think we fixed the second one now as well. We're ranging about 84 pages a minute. That's a good number to flow. Okay, the second one is also done. We are at 69 pages a minute. It's okay. Now we are 116 pages a minute. Oh, this is great, good stuff. If you were to have 116 pages a minute, if we even just go through a flow of 100 pages a minute, yeah, we can just get entire docs done in 2 days, less than 2 days, maybe maybe less than a day sometimes. I don't know. We'll have to check. Embeddings are being generated, so the VLM entire stuff is actually done. So you can see annotated numbers, 13 tables, 71 figures, generating chunks. Good. We're still at 86 page. Yeah. So depends on the document. Some documents could be huge. Some of them might have a lot of pages and etc. The range should be around 100. And you can see we're ranging at 0.71 seconds per page, which is that's the number we want. We want to process 0.5 to 1 second. We want to do one page in 0.5 to 1 second. That's the ratio we're dealing with. That's the ratio we want to deal with actually. Okay, so nice. We actually done 100% done. Damn, this is good. Now we've excluded the 171 MB doc. We'll come back to this later. There's a small scale issue with this. We'll fix it right away, but we'll just focus on this for now. And average is about 1.36 a doc per page. Decent number. Because certain pages can be like high quality. Then you need excellent results. You have 6 workers, 3.1 docs per minute, 1.3x scale. 6 workers, and we're doing about 109 at an average pace, which is a very good number. Through output is very good. Wall clock is 1.3. Yeah, 1 minute. We actually processed 5 documents in 1 minute and 37 seconds. And we have per doc average is about 59.2 different docs. Scaling isn't perfectly linear. Expected 4.8 documents per minute, but that's because different test scale 60 has hard documents. Yeah, exactly. Some contention on shared resources VLM, still 109 pages for this thing. So we'll just quickly ask, keeping an average, assuming that there's 50 pages in 10,000 documents as an average. That's the worst case scenario. Sometimes some of them will be 20 pages, but keep an average of 50 pages per 10,000 documents. At this pace, how many hours or days would it take to process all 10,414 documents? Now we can still bump it up. You can see we have another 20 GB of VRAM left. You probably can add dockling and also slightly increase the batching or the concurrent batching for each of the VLM requests. There's a possibility here, but I want to keep it at keep a buffer of 7 GB because sometimes stuff may, for example, you see over here, right? There should have been only 70, 60 sort of 60, 65 sort of GB, but it's 77. So things can go up and down. It's usual, but yeah. And at current pace, actually, we might take about 3.38 days. Okay, that's hard. That's bad. With 10 workers, it'll take 2, and with 20 workers, it'll take 1.2 days. Now we have our 6 workers. Okay, we'll do something like this. Okay, now I have a document. Okay, the thing is like this. I want to also test scale. I also want to test the scale as well. So what I want you to do is that I wanna, now we know we fix the issue. I want you to check dockling on how to. We've already done this before, but you can search it up again for dockling. How to make changes to the scale. So if the document is more than maybe like 30 MB, then we scale it to point. Yeah, there's 1.5 or something like that. Check on this and let me know. So because there's a good chance that we might deal with documents which are 170 MB. That you can still deal with. Some of them could be 300 MB. You might not know. So in that case, we want to lower it down to a good ratio. That's what I'm thinking. Because the thing is, like, if it's very high quality, if it's full of 170 MB, even if you put it down to 0.5 scale, it's still high quality. For example, if you know images, we work with photography, you have 8K image, you scale it down to 1080p. 1080p is still accurate. You can read text, it's crisp, and it's not crisp as 8K, but you can still read. That's the amount we're dealing it, because we are scaling it from the original ratio. Original ratio can be 4K, 8K, whatever, 1.5 of that. So you can assume um, it can be effective. So the image option exists, but it's being passed to. Let me implement dynamic scaling. Yeah, let's do that. And depending on this thing, if it's 50 MB, if it's greater than 50, if it's less than 50, no, will be like, if it's more than 50 MB and less than 75, then we keep it at 100 one. And then if it's more than 100, then we keep it at 0.5, because we can't afford to process 100. No, we can actually, it'll take some time, and okay, it should take some time, because we are actually that's what we want to do, accurately pass stuff, but also we can't waste weeks staying up until it does all the work. So yeah. The thing is, I want to test it again with this 77 GB, right? I want to again once more test this one more time, just to see how much of, now, for example, the max could have been 75, 75, or you have in memory, you have 77 gigs of VRAM. We can again process this and see where it's actually bumping up. If it's going above for each request, for the same request, if it's bumping up a couple of GBs, then just assume, with a lot of the requests, it's gonna bump up. And there's we have to probably, there is something, some state or state level cache or state level something is there in the GPU VRAM. What we have to do is that once you process it, just flush that out and pull in the next one, flush it and pull it the next one. So then it's also efficient. That's that. I think it's efficient. I don't know. I have to check. Let's go for one. So 171 MB will be 70 MB, still low, but actually we'll do like this. Now the thing, yeah, so the now thing is like this. Sometimes a document could be 200 MB, right? Then we can't do 200 MB. We wanna get to 0.75 or something. But if it's less than 50, we can do one and stuff like that. Like, it needs to have some decent logic. Could we specify 0.75 or one, or is it just one 1.52? Is it like on that order? Yeah, we can do any scale. Okay, so we'll do less than 30 MB, we'll do 20. We can accommodate it. If it's 30 to 100, we'll do 1.5. If it's 10 to 200, it's one. Yeah, we'll actually lower faster. Yeah, this is okay for now. We'll proceed and check the difference. This will anyway be slow because it's actually a 50 MB PDF. So it'll definitely be slow, but still, I want to first of all check, you know, yeah, let's do one thing before we test it. I want to check the quality of it for a test. So then I would know even a point 0.5, scaled down version of a document that is in 200 MBs or something like that, depending on the pages, would actually, if it's high quality, then that's good. That's what we want. Because that's only for images. Like you take a screenshot of an image and then you pass it. That's the thing. Now auto detect image skill based on file size is not provided. Now I also have one more question. For example, initially we process all the images and all of those stuff, right? You know what we do, and then we get access to the pre-processed basic C4 whatever, and there's only one docking per initially that runs for a document, and then sends all of those document class down below. Now, I'm curious to know, will the image, because you're passing scale to the image level, will now already the image is scaled down and passed. Would you still scale it down and then do you pass it to the image models? I'm just curious to understand because there is no way to auto detect and etc. because oh maybe you can do it, but dockling does all of the process and passes it. That's it. There's only one try you do for a dockling and then you process all the pre-computed stuff. You understand what I'm trying to say? If not, yeah, hopefully you should understand. Because I think I'm guessing what it's trying to do is that you have an image, you scale down to 0.5, and then you also there's a code to send. These are pre-computed. We have a graph here on the architecture we're trying to do. And anyway, once this project is done, I'll leave all the code. But this is the architecture here. And here we actually have one phase one to CPU pass, and that's it. And afterwards, it's layout GPU and then VLM. After this, there is no going back to Dockling. You understand? So there is no scaling down and all. There shouldn't be. If not, the the package will get into thread. The thread will lock. Entire thing becomes sequential. That's what we're fighting for. Good question. Yeah, thank you. Extracts images at scale 1.0. Basic so sends to workers. Receives image. Resize it. Can't really it resize. Yeah, this is okay. If it's above more than 1536, it's can resize. So potentially double processing. Dockling extract scale VLM caps. Yeah, but there's only one docklink that initially runs, right? In when you resize image, you don't use docklink to resize image, right? That's my question. Correct. Docklink only runs once to extract images. VLM resizes. Okay, Python imaging library that has thread request. That's okay. Okay, got it. Makes sense. Let's proceed for the next. Yeah, if your scale changes are done, we can start testing it. Yeah, one more time with this 5 documents or this current test 6, which only has 5 documents. And then if we get the same results, we go back and test the 24 documents, and then we will try to come to a conclusion on where to increase workers and etc. afterwards. Just reaching at 109 documents per second. Now let it complete the stuff. After this, Yeah, before I start, just check the files, and also if you can put back that 172 MB file to this folder so we can test it in a go. Actually, no. 20 MB, 29 MB file and 6 should now be. Just check test 6 and see do we have what do we have a 29 MB file? Oh, maybe that's the last one that was processed, if I remember it right. Yeah, that is a 29 MB file. It's okay. Yeah, nice. Process, and then that, okay, then that was quite fast as well. Lower the threshold 25 MB from a scale 1.5 or keep it as it is. All files are. No, it's okay. 25 MB is fine. You can accumulate it. Now we'll run the test. So it started 6 workers. You can watch the changes. Now this won't actually show us anything new because we already have uh, because we are testing the same thing. Status 1 out of 20 is processed. Watch this. Second one also done. Already 80% done. Just last document left. You can see we already processed 117 pages and full done. Good. Good. Scale is not. I mean, yeah, scale. We don't still test scale here because we are not what do you call? We are not yet in this threshold. It's 25 MB, not, and the file is 29 MB. So you didn't get it. Results looks good, which is good. Pages pending 106. Yeah, you just need to get the range. That's it. Scale didn't break anything. All files were less than MB, so scale was true anyway. Read this thing, and we'll test this 24 docs now. Okay, let's flush this. Let this flush. Going down. We'll do 6 workers. Run how 6, and we'll run this. Okay, so it started. Okay, and you can see the bump in the GPU. We're already at 80 GB, and I can see that accumulation happening. So that's an issue. I think something is stored in VRAM and it doesn't get offloaded. And again, when you process, it's still loading more, and again you process, it's loading more. It's just keep on loading more. Yeah. Let's see. Focus on this GPU count and everything. Maybe I should. No, I guess you can see. And some of the documents, for example, this 401 and all of this is processed through scale of 1. This is processed to scale of 1. So scale is also working. This is processed in a scale of 1.5. So it's something less. It's less than 100 or something. I think I don't remember. But yeah, we have 4 completed, and these are quite huge documents. One of them, consists of a lot of pages. I guess nearly 70 pages, and the other one is dense with quality. So that's one with 172 MB document. Yeah, but still we're ranging with 90, 90, 99. This is what we have to focus on. Sometimes this could take a while depending, because at the end of the day, a PDF can have 10 pages and one PDF can have 1,000 pages. You would never know. So your throughput should actually be in this range. As long as you're in this range, you're safe. That 100 pages per doc sort of range. And this will go down next, I think, because right now we are probably processing a dense document. I think we'll hit another issue. I can see over here, page 0 has 0 content blocks. Yeah. I'm worried if if these documents actually need OCR. Annotated fiction. These are images are okay. Some of the documents need OCR for text, even for text, because some of them are scanned copies. And general scan copies, you can't grab text like properly. And we're only doing layout detection. Yeah, I think we'll hit a road bump here, definitely. I can feel it next. That's what I want to see quadrant and see the chunks and verify chunks and etc. Yeah, but at least we're doing a good per minute, per pages per minute sort of ratio. We actually at 138 pages per minute, and some of the documents are actually huge, 110 MB, 117 MB, 150 MB. So this is a good number, and we're doing 0.78 for we're doing a document for every every page per 0.7. So less, you're processing like 1.5 documents every second. That's very fast. And the maximum was actually 3.7 seconds. Maybe it had a lot of, I don't know, whatever the stuff it is. And we're doing concurrency 6, that we can actually do more concurrency. We can do another 10 gig of concurrency. So load up another 2 or 3 docking. 6, we can do 10. We can do 10 workers. I'm only worried if we need OCR. If this, if we let's check the text, we'll check the text blocks of quadrant. I can see the 0, 0 chunks being retrieved. I don't know if it's like a very baby error or something like that. In case page 0, context of page 0. Okay, it's actually page 0 sort of error, I think. Other, we can check quadrant, and if it's good, then it's good. Again, we've already done. We had 138 pages a minute. It's quite good. 141 pages a minute. Nice. Damn. Actually, this is what we spent like, I don't know, easily 3, 4 days, 5 days figuring this out. I don't have any experience in this infra stuff. If I were to work someone, I usually work with people who have, who probably have done stuff at scale. I've done similar work, but right now doing the infra for it is totally, it's a different ball game apart from all this building agents and everything. And yeah, I'll write a blog post because you can't see the entire video. I'll write something on Medium or write some sort of 166 pages a minute. Nice. Yeah, so this is a good range. Within 166 pages a minute. Very good range. I was expecting to be 100, but 166. And I think we can pull off 200 if we use that extra 10 GB properly. We can pull it off. And yeah, again, coming to the point, I'll run a blog post and I'll just, put in all the challenges you might face. And yeah, this is not related to agents. This is not related to any, like complexity and stuff. This is just pure infra. I guess this is how big companies would try to, not like this. They'll have, PhDs and etc. But, we are doing something decent, and this is something, you can also, take inspiration on, depending on, the servers you work with, GPUs you work with. I work on an H100. If you work on a B200, this can be 300 page. The processing times would be much faster. And if you're not using dockling and you're not, dependent on any thread pools or any issues on PyPDM, you can actually skip that, write your own stuff, and you can range easily 500 pages a minute. Like that's what you want to focus on. That very simple goal, right? That's the general that's the general sort of general ratio that you can think of, which is that pages per minute. You can depend on that because that's the fixed general factor there. And then what you have to do, keep a goal of processing this and that in whatever the amount of time you want, and then try to write your stuff and wrappers. If you have really custom stuff, if you write stuff on C++ and Rust, it's much more faster. You can easily range from 300 to 500 pages per minute. And if you have a lot of GPUs, then that's 1000 pages a minute. If you have a couple of two, if you, let's say you have like one B200, that's more than, I guess, is 150 GB. One B200 is more than enough. If I could have afford, if I had the resource for it, I would have definitely showed you guys how to do it. It's much more faster. You have all the drivers, yeah, based on Blackwell, quite fast. This is of course this is the second to third generation. NVL is third generation. At least we're ranging at that 135 to 150 stuff. So yeah, pretty okay. And this, I'll also keep the code in a very decent way where you can, depending on, the RAM you have, you can load in models. If you want to enable OCR, you can do it, and, sort of like that. I think dockling is a big blocker. Maybe, we might, yeah, no point, like, no, maybe next time if I were to do something like a series like this, I wouldn't use dockling. I would do everything custom, so everything thread pool safe, no locks, yeah, stuff like that. I'll focus on that initially, think about those stuff. This is a good lesson for me. I didn't think about that at all. You should definitely, if you're, working with big companies, you will have people to think about this and, make decisions and all. Yeah, and especially in enterprises where you have a lot of documents, stuff will work for one, might not work for the other, and etc. So you will constantly have those issues. Okay, so I think total CPU time 42 minutes. Yeah, don't focus on total CPU time. This is definitely not 42 minutes. This is CPU time. So we're running six parallelly, right? So even if one takes about 2.6 minutes, we've already done 22. So you do 22 by 2.26, then you end up in something like this. So that's the parallel, like that's the CPU time, like the compute time, parallel time. We actually started with 8 pages a minute, 8 or sometimes even 3.5 pages a minute. Now it's 160 pages a minute. Eh, but I think it's stuck in this one. Let's see. And maybe this is a huge document. There's something failed over here. We'll copy this. Yeah. And this, yeah, this is trying. So the failed one is being tried again. You can see 296 tables, 84 figures, 0 formulas. It's very dense sort of image, I think. I think that will fail, and I'll keep trying. I think, yeah, that's what it's trying to do. So I guess it's batched all the, so you can see 296 tables, 84 figures, 0 formulas, sending 380 VLM requests. So that's where you can see this is 100%, and if this is fully used, utilized. Now we've done, actually it's quite fast, I would say. This will drop. I think this will drop. Now it's embedding all the stuff, but you can understand the scale. 380 this in one forward pass. If not, what you have to do is that you want to do forward pass. How much? If you do it parallelly, it'll be like 1, 2, 3, 4, 380, or batch it, then divide by 3. Then how much? 300 divided by something around, yeah, 190, 120, something like that. That'll be one, like 120 forward pass. This is only one forward pass. Actually, no, I would say 128. So 3 forward pass, 380 requests is done. So it's quite fast. Do this. PowerPoint presentation. So this is a PowerPoint presentation. I saw this image. I'll show it to you. So for this, we have to deal in a very different way. Yeah, I don't have, I don't have, for example, say this is the one, AII, whatever. Dense with images, you can see the number of pages, and then everything is like graphs and etc. So for stuff like this, where it's sort of like a PowerPoint presentation, we know it's totally images. We need a very different way of handling it. But yeah, that's maybe something for the we have to take care a bit later, not now. And one failed, I think. Two failed. 8% failure rate. Actually, copy this so loads can see it. Put it here. The test is nearly complete. 24 document. Final says 90% complete. 23 successful. 25. Yeah, there was one corrupted document. Server disconnected there. Oh, okay. Okay, I didn't know this. I thought it was corrupted, I think, yesterday when I checked it. And we made changes to the code. 162 pages processed. Performance. Yeah, so the thing is like this. We have 10,414 documents. Even if we range for 9,000, some even like 1,400 documents fail, or maybe 400 documents fail, it's totally okay. Like in terms of ratio, you will have that, 3 to 5% of failure rates. You have to accept that. You can't get everything right here. A notable completion from logs. This is for an image stems. 114 pages. Retry in progress. Okay, so I don't think we also made some changes to the code where there's no one retry. Currently processing after initial failure. It doesn't, the retries won't process. We made some changes to the code. Issues, the two failures are from docklink connection drops, not VLM. The retry logic is working. Failed documents get recubed after 60 seconds. Yeah, okay, 2.5, we can finish it in 3. The async optimization is working well, 481 current requests. Okay, now I want to discuss something as well. Good. Now we basically ran all of this stuff, and this is the current GPU memory. I can see something here where for each request, the GPU just gets adding up. After, let's say now it's currently it's at 79, right? When we run this request again, it'll become 83, and then it'll stay at 83. And then when we run this request once again, it'll actually stay from 87, and it'll stay at 87. Like that is actually accumulating, and something is accumulating, and it's just staying there. I don't know what is really there. You'll definitely have all of the dockling stuff. You can see the split of the GPU consumption, but I'm definitely sure something is there that's catching, holding on to the memory, something that we should not hold on to. Because see, we are processing a lot of documents. By the time we reach 1000, 2000, 3000 documents, we don't want that very small accumulation to be in GPU memory as well. I don't know what it is, but I can feel there's something. And then in the middle, you'll have this GPU memory not available error, and then everything will crash. Like, we can't do that, we can't help it. So I want you to spend some time on it. Yeah, right now pipeline is working, but we can't afford to have issues like this. Go back. Right. This cleaning GP memory basically offloads all the models, or what really happens under the hood? I want to understand. Explain. Okay, and this also doesn't interfere with VLLM, right? For example, right now when you make a batch request, it reuses KV cache. Oh, sorry. So this doesn't affect the process of VLLM, right? Because right now, if you process a document, it reuses a lot of KV cache. It reuses some. It batches concurrently and reuses some KV cache. I read about it, but if it doesn't affect this, yeah, you can make with this. Go ahead with this change. Okay, yeah, it's fine. Oh, actually, we have actually processed those much of documents in 5 concurrent workers. Okay, I thought it was 6 actually. 2, 3, 4, 5, 6. Okay, and we'll run concurrency 6. Just wait folks. Should pick up everything. So you have 6, 3 here, 3 here. Sometimes this might slow down because this might do a bit of cleanup and then you're loading it again. Those might take a couple of seconds, but I actually don't know. So we have to wait and we'll see. And you can see all of this, it doesn't exceed more than 5 GB. Before, I guess, before if I want to see, this is 4, this is 3, this is 5, this is 3, 6, but you're seeing everything is around 1, then 1.2, 3.6, 3.33, so well under. And you can just jumped up to 79, but we're still roaming around 70, 76. This with only four docking servers is, sorry, 5 docking servers. This is 6 docking servers, additional 5 GB, but we're still at that 70 GB range and still ranging about 103 pages per minute. Then we can actually, with this efficiency, we can actually bump in another 2-3 workers, maybe 10 docking servers. Yeah, we'll try 10 docking servers next time. Even though there might be a small, few seconds gap, but still that gives us an extra 5 GB, then another 1 worker or 2 worker docking worker, and 1 docking worker can process documents in, I don't know, 2-3 documents. So it's like a, yeah, it's like a very good investment sort of thing. And it's actually nice. We're well under 70 GB. So you can see this is 1.2 MB, 1.2 MB. There's no accumulation here. You can see that, and everything is less than 2 GB right now. And that's what, so images and everything so PyTorch stuff, the libraries and everything work hashed with this memory. Right now we've free it up, delete it, and then restart from that. That's why it's actually under 2 GB. This might affect a little bit on, you can see the minimum to 1.23 seconds. The last time minimum was point something. This will definitely affect a couple of seconds. I think, as far as you can see it was 0.072 seconds. That's the minimum, and the average was 2.3. We have around 30 seconds extra. Oh yeah, we have to wait and see the final comparison. And I also think for embedding, we are only able to embed one thing at a once. So I want to check two things. I'll write it here note. Embeddings need to understand parallelism here, because two docs can two docs can two docs um, ingest embeddings to quadrant at the same time. Because I can see here quadrant seems to be sequential. One pops up and then the other one. It's okay, because you might need you don't want to jumble any chunks and etc. So um yeah, it's okay for now. You see here 217 VLM requests. Then it'll complete in two forward pass. One is 128 in one batch. Sorry, yeah, one single batch. This is 481 VLM requests. 45 tables, 436 figures. It's done. And you can see this is done. We're only taking sequential embedding time. So this embedding is being saved sequentially. 128 at the time, I think. We have one failed document. Last one is being processed, I think. No? I think it's done. One failed, one processing, but it stopped over here. And the range is good. The range is okay. So I'll send this information. Much better. and you can see it's well under. Last time, if I scroll up to the history, you can see 79 GB. This is once we finish everything. We finished all the inference, and we had about 79 GB. Now we finished all the inference much quicker. Sorry, much quicker. Okay, now I guess it's retrying the failed one, so we'll wait. And it's still less 10 GB of extra VRAM is being saved over here. So we'll send this information, actually, this one. Much better. Put this information. Here it is. This very efficient, very efficient. 14 GB saved. So Dockling instances now stable at 1.2 GB each. 24 out of 1 failure versus 2 versus before. 161 pages per minute, up from 139. Time clock wall. Okay, so we're processing in 10 minutes. We're processing how much? In 10 minutes, we're completing 1652 pages. GPU temperature 64 Celsius, healthy. At 165 with 50 pages. Yeah, for 520,000, we're assuming there's like 50 pages per 10,000 documents. We'll complete the entire thing in 2.2 days. And now the memory will stay stable throughout. And now what we'll do is that looks good. Now update the phase for document with this. Next, I want to bump it up for 10 workers. So 10 Dockling workers. And I want to test the stability of it. So far, good progress. Let's update the phase for document with this info. So this has the cleanup has actually helped it. Now we might have to do some cleanup in this VLM, or maybe not. Let's actually scroll up and see the old one. Old one is 55. This is also 55. So once the request is done, I don't think there's any cache or nothing is stored for temporary allocation for the old VLLM. I think it removes everything. It does a good job for it. So we don't need to do anything. But I don't still know. I have to still verify the complete pipeline and see. But if we go in this speed, then if it takes this is with 6 workers, and if you have 10 workers, that actually adding 40% of speed. So this everything could be done in 6 to 7 minutes. But you will definitely have a little bit of congestion, but maybe with this we can actually do all of the 24. Of course, one is failed, but still that did process, I think. So we can try 10 workers and see where it leads us, and then we can go from there. Okay, I just saw your message, Pro Education. What are you building? I am new here. So hey man, I'm not sure if you're watching this. Probably I think I just got a chat because OBS doesn't, for some reason, just show me the chats. So I just saw it now, randomly loaded up the video. So yeah, we're building a RAG system for NASA, for a company that works with NASA. It's a fictional company called Meridian Aerospace, but it's actually like a real world project. Nothing, no different than a real world project. Here only I'm the one building on it. The first few days we solved document processing. Second day, in few days we built the agent. Right now we're building an infra that can actually process 10,000 documents in a day or so, in a day or two. So we only have one H100, and we only have very limited amount of compute, and our documents range from basic documents to scan copies to handwritten to technical diagrams to images to figures to tables and formulas and etc. Very complicated. Some of the documents are 4K or a scan. You have 170 MB documents, 200 MB documents that's only 10-20 pages long, and there's a bunch of issues. So we only have very limited amount of compute, and we also have been using Dockling, and Dockling has a very small, not sure if you have used for PDFs and etc. They have this issue with threads. To simply put, you can't parallelly, unless in a given, let's say you load 2 GB, you can't do the entire dockling process for that entire 2 GB of VRAM. You can't do batch processing like VLLM. So what we're trying to do is that making sure we use it efficiently, we are actually loading up dockling models, just models per se, to do a lot of layout detection parallelly. So then we are bypassing that thread issue. sort of thing. So I'm sure you might be sort of wondering what we're trying to do. It's just simply we're just trying to build a system that can work with 100,000 documents documents, and these documents are actually pulled from NASA. So just to show you some example, these are the type of documents we work with. Very complex, not very complex, but some decently. It's not your general legal document. It's not your general financial Excel. They have you can see the amount of scan, very bad scans, and you also have here a lot of diagrams. You have a lot of pictures and etc. So this is what we're actually dealing with. So yeah, if you are very interested in building stuff like this, make sure, depends, like this. If you want to only learn how we built the initial agent, watch part 3 to 5, I think. If you want to do document processing, learn from 1 to 3. But if you wanna work on know about infra, how to do all of those stuff, watch from 6 to till now. I think about 6. I was spending time out of 5 days, but those are very inefficient, and some of them were very buggy days. 11, I spent like 7 8 hours, 9 hours, 10 hours working on bugs only, and then I rewrote the entire architecture. Right now we have a new architecture to do something like that. We took inspiration from companies, how Scale AI, OpenAI, Claude. These big companies really focus on a lot of memory, very minute pieces, nuances, and etc., and build very different services that the CPU that is uses GPU, and then some caching, Redis, and etc. So we take an inspiration from them a little bit, and of course with the help of Claude we're able to build something decent. Yeah, so if you want something like that, don't watch the entire recording. I'll leave like a Medium article or maybe some article I write later. I use Cloud Code to just analyze this stuff we've done, because we've done a lot. There are a lot of issues. I just forgot a lot. I'll do that and put it down, and then you can actually, yeah, you can actually see that and take some yeah, information and build it on top of them. So yes. Şimdi konuya dalıyorum. Also with that, I also want to with this I also want to understand our retries, because let's say when we're processing a lot of stuff parallel, right? I want to know about retries, because retry do not want to complicate or take compute from the current batch. We don't want that to happen. It doesn't need to interfere with the current batch and cause inefficiencies. At worst case, we will process all of the failed ones last manually if needed. Okay, and I expect to at least have 1,000 failed docs easily. I think we have the 414 exactly, and 1,000 docs might fail. 10% ratio, we can keep like a 10% ratio, because some PDFs might be corrupted. There's no way you can bypass it unless you do some custom work to it. So yeah. So we'll validate 10 worker, and then if there's space, we'll see whether we have to bump up the worker or we have to bump up the sequential processing. So instead of 128 in a single go, if we can accommodate 256, we can do that. Okay, I want to start fresh. I want to kill Dockling, flush Redis, and then start the concurrent workers within. I have the command. Just give me commands to um, kill Dockling and yeah, just command to kill Dockling. Actually, you know what? I have the command. kill all the docking services. We only have embeddings and we have the model running. Same 55 layout. Start this one. We'll restart the server. We don't need to restart. It can catch on from where we left. And here concurrency will be 10. And yeah, and we need to start. I'll start docking. So we'll start. You might need to update this file. And we'll kill this one more time. Then start it. Okay, now we run this. It's already stopped. We killed it. We just run it. Instance on port is not running. Okay, it's all stopped. We'll start it. Give it a few seconds for everything to load. Then we're going to start the process. Start in Corpus. Retry. Okay, process is started using H09, and here you can see expand this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 Python. Okay. Everything is running. Let's watch the progress. Up to 92 GB. I think this might crash. Let's see. Get something. All right. Sorry, guys, had to go and take some food. And yeah, the range is 180 pages per pages. How much? Pages per minute. It's sorry. Our previous range was, I don't know, but I didn't get a chance to see the peak because I wasn't there. Shit. Peak GPU width. Last time was 165. This is 180. That's it. Small bump. It's a huge bump. Wall clock 9 minutes. Not a big difference. It says 8.5 seconds. Yeah, we got like 50 seconds faster. 180. Yeah, success rate same. Plus 56% saturation. Dropped by a minute. So just we're approaching LLM saturation point. Yeah, you'll only have a point. You'll only have a point where you can go, and afterwards it'll saturate because some of the internal requests might hold up in the GPU and etc. So what we should do is that I think we have memory, but wait. I think our VLM could also be blocked by the batch request. How many concurrent requests do we serve right now? And could we serve more? Could we serve the double of what we have right now? So what we can do, even the Docklink gives you a lot of requests. VLM should have the batching capability to handle that. So it both goes hand in hand, guys. There's no one solution works. You just have to, think through this and, find the best approach. Simple. And yeah, you just have to find the sweet spot, and you can't plan for it. You have to test and test and test with a very small set of docs and see. and my goal is to get to 100 pages a minute. That's it. Now we do 180, and after the change we might do 250. But when you're processing, I don't know, yeah, when you're processing 10,000 docs, you might have some compute issues. I don't know. Even if there's a 50% drop, worst case, you'll still will end up on time, but it won't. We'll end up early only. I'm just saying. Only 120, only 50 of the GPU with 10 workers. Each document could be 400 to yeah, exactly 50 to 400 concurrently. That's big. PowerPoint had 481, yeah, 4xr limit. Request about 100 Q, yeah, exactly. So this is blocked. Even though dockling, it extracts and give you the info. Dockling is waiting, and this is blocked because there is no VLM used, like free memory used. So what we can do is that double this to 256 and increase this slightly. Yeah, we'll update this and see, and we'll measure the performance and see, and we'll go until we notice that saturation, and then we'll come down, find a sweet spot, lock it in, and then you know yeah, just run it for all the documents and we're done. We should be good. So we have 16 GB free safe. I don't know if it's true because I saw in one point we hit 92 GB. We'll just try and see. We'll just try and see. Okay, we killed, I think we killed Docker. Did we kill? Ah, yeah, we killed and restarted it, I think. It's loading. Um, it's loading. It's loading. 60 GB now, and we are totally at 78. Still huge risk, big risk because all of this will double, and we might run out of GPU memory. Let's see. Okay, we'll try. The process should have started. You can see the bump here. I'm expecting this will fail out of run out of memory. It's already 93 because we are removing all the memory, right? Once we process something, we remove the memory, then we might get lucky. But yeah, for example, one is done and you saw the one of the memory was done. It's totally removed. So yeah. Hmm. This document failed because of this error. Copy this and keep it. Embedding is also having some efficiency issues. Let's note it down. Now we're doing 48 pages. I think this will be a little bit slow for some reason. Let's see. Some 7 pages a minute, slightly increasing. As we go on, we increase. We'll get into the flow. More than the flow, it's actually about the type of document. This should have been fast, but yeah. 83 now. There's no obvious increase in speed. I can see that. I think 6 workers is the sweet spot. Maybe that's the thing. Keep at 6 workers and then double the amount of sequential, what do you call it? Sequential number of requests you can do. Okay, that's the sweet spot. Let's see. We don't 122 pages per minute. I don't think we have a big change here. No, I don't think we are. There's some issue. I'm not sure if we are actually using the 256 requests. Mm. I know we loaded the model with that, but maybe not changes. Are you sure the model can handle 256 at a given time? Because I'm not sure if uh, the change is visible or whatever. Because I'm not sure. Um, yeah, you have to check. Just check the code if the change you made on 256 is actually being used. And also, I'm not sure if the memory needed to process 256 allocated is also enough or quite enough. I'm not sure if that's the case. At Yeah, because I want to validate this. If then in the future, because there's no big difference, right? What we can do is that we can have six workers, but increase the amounts of sequential processing we can do or concurrent sequences. If what we want to verify that whether it's like, and we can allocate more memory for 256 as well. And yeah, and also yeah, I have another issue on embedding, so I'll talk about it later. First, yeah, check on this because saving embedding is also taking time, and the 5 GB doesn't seem to move up. So maybe embedding itself, it can process 120. I did 128 embeddings now. It can maybe process even more embedding, so you can process one embedding in one particular call. But not bad, 184 pages a minute. At worst case, let's say 150 pages. Let's quickly use GPT. Yes. Assume we have 10,000 documents and each of them have an average 50 page document. If we process 150 pages a minute, how many days would it take to complete all 10,000? Now, I am thinking it'll be, if it were to predict whatever the prediction is, it'll probably be a little bit lower than that because not all the documents will have 50. No, average will be less than 50, like 30 odd, 30, 40 odd, maybe 50. Max will be average of 50, 2.31 days. So if I run it today, 26, 27, so yeah, will be fixed by next Monday. No, sorry, not Monday, Thursday. Yeah, but we don't need to wait for anything. We can, start the stream and we can start working on the agent and etc. Nothing is stopping us. Sorry. Yeah, yeah, we'll actually try this and see. What we'll do is that we'll reduce it to back six workers, but we'll keep it at 256 and see. And then from there, if we see a slight improvement from the original, we'll keep on increasing the sequence, like from 512 sequence or something. Yeah, first we'll get it to six workers and uh, try 256 and see what happens. So this start with 6. I'll also stop. I will also stop. What is this name of this thing? Doclim, because it will take, three or four. It'll take some RAM, so we can just get rid of that. Okay, starting. 1, 2, 3, 4, 5, 6. 6 is starting. Let's see. And you can see it's randomly loading those 5 endpoints. So we have around 3-4 GB of just caught up VRAM, which can be removed in a real world scenario. We don't need, if you only need 6, then we only need 6 toggling. No more, no. Sorry, no. We don't need more, we don't need less. Yeah, oh, nice. 202 pages. And this is with only 6 workers. So the bump in sequential processing is working. We are 202, let's say. Oh, no, sorry. I'm wrong, actually. Yeah, we actually low 78.9 pages per pages a minute. 86 pages a minute. Yeah, I think we're passing this collection, and because this collection doesn't exist, everything is stored in Meridian documents. This one. Yeah, seems fine. And there's actually how much? 34,395 chunks already. Because we ran a lot of tests and etc. Embedding is actually sequential. That's why the other document, even though it's done, it's waiting until the other embeddings is saved before it can put in this embedding. Now this is worst case scenario we're handling. 481 VLM requests. Usually that's not the case for one document. And we should have done something different for PowerPoint, but it's okay. Can't afford to spend time right now. We're already late. Okay, now this should be quick. Saving embeddings. Oops. 31. Yeah, exactly the same. Can you quickly connect to Dockling, sorry, the VLM Docker and see what was the KV cache usage, just to get a slight idea. Were we utilizing it fully or just a little bit? 40%. That's what. Or maybe no. I can be wrong. There's more info here. Max is 84, I think. I didn't know 99. We did use it. More consistent high usage. I'm sure why there is a little bit of idle time. I think it's maybe because we are blocked by embeddings, and I mean, I just visually went through this, but seems like I see all the embeddings generated, and then another documents embedding comes in. Are we calling embedding sequentially or parallelly? Can you please check on this? Or again, for same thing for storing as well. Just curious to know, because if we need to wait before other documents embedding comes in and this finishes, if you're doing embedding, saving, embedding in a sequential process, then that takes time too. Don't make changes to the code. I just want to know. That's what. This is where VLM is actually idle. When docking finishes, VLM starts and debugs. Yeah, not sure if it's possible, but probably there is a way. Definitely there is a way, and probably it's we can make it async. So please do some research on this, and yeah, feel free to launch a sub agent to save context and then come back to me on how we I don't want to get into any bugs, and I don't want any incorrect stuff to be added to my to be generated or maybe added to the quadrant. So we need to make sure it's accurate, and because a lot of dependable components. But if there was a safe and very accurate way of making embeddings async, sequential for generating and also putting it to the quadrant, then it should be great. So launch a sub agent and come back to me. Also, quadrant GitHub. I'm using quadrant for embeddings, right? So I'll do cd isn't it like to next step. Okay, we got back. Okay, let's implement this. Okay, now we'll go ahead and test it one more time. And close this, we'll refresh. I guess the embedding was quick, generated very quickly. I think we also, I think maybe we just check on this and give me your thoughts. I think you can. How much are you batching per embedding? I think the embedding VRAM doesn't even move. I think we can also, like, for a single embedding call, you can get a lot. Like, you can send more or batch it or whatever. But still, it's 174 pages a minute. Still, yeah, 5 to 6 pages more. Hey, embeddings, right, can handle 256. Also, can you check Olama? Sorry, can you check VLLM's Docker logs? Can you see is there any idle performances, anything idle, or how is the max usage and everything? Let's make it 8. Is there availability of RAM for us to process and make it increase it from 256 batch size? Because I think we have another, easily we can use another 10 GB. So I was just curious. So we're making it 8 and then 512. And 10 is ready. Maybe you need to stop the Docker model and restart it, right? You have to allocate more memory for it. So then only it would actually use the 512 embedding batch, right? Because right now we've only allocated point something, I don't remember. No. I meant VLLM. Like we started VLLM using Docker, and we've given it very minimum amount of GPU, right? For it to use the extra 10 GB, you need to increase its GPU utilization, right? I mean the VLLM, GPU utilization in VLLM. See, only 0.65. Have to maybe bump it to. No, I don't think we should bump it. Mm. Slightly, a little bit. Slight. Actually, we'll start it like this and make. Mm, I don't know. There was already 215 requests processed, right? This is overloading the model with 512. We'll try and see. We'll try and see. So check uh, check VLLM Docker and see if are we still having that same gaps or any insights on that. I think we don't have memory to serve that 512 chunks. Sorry, 512 batch requests. If not, we can actually afford. We can, because see, we have 8 workers, but we still have 1.2 GB, 1.2 GB of GPU piled up. Let's check this. 137 gigs. And that's only a slight improvement. I guess this is the number, guys. We'll stick with this. I think this is good enough. Yeah, and what's the last API call? What's the last embedding that's processed? I need to know. Is it a failed doc? What is it? Because I see the salary worker stops and then it starts putting embeddings on something. I shared the logs above. I wanted to know what it really is. Corruption, corrupted documents. So only if one failed, leave it as it is. So this is good enough. So just curious to know, is there a quick way for us to check how many pages we have in the 10,000 documents? 10,000, it's actually stored in mount mnt slash data somewhere. There's about 10,400 odd documents. Is there a way to quickly check how many pages we totally have? And I don't want to spend too much time in it. I don't want it to take hours and etc. But just wanted to know, is there, could we check that quickly, how many pages we have, so we can make so we make the calculation better? Because that sometimes if we were to load PDF, the uh, plugins for everything, then it'll take, and 10,000 will take a lot of time. Now we are averaging 50. maybe it might be more because I've seen most of the documents are 60, 70 pages. They're not basic stuff, right? Rocket stuff. One like they're not like each page would not have a lot of text, but they have a lot of diagrams. So that's what I'm just thinking. So sample 100 PDFs to estimate total pages. Yeah. Hmm. Actually, how long will it take for you to check for the entire 10,457 die? Will it take like a few 10 or 15 minutes? Is that the time frame to check or to run the code to access all the PDFs and access all the pages? Because I want to accurately know. So, and some of them could fail here. Like 10% of the files can fail here. Which except parallel, it should take 2 to 5 minutes. Ah, okay, then that's fine. Let's run it. Give it some time. 180 pages a minute. I actually expect this to be average 64 because even if I pull up the documents that I have over here, everything is more than 30, 40 pages easily. Most of it. And this is even, I don't know, so how much? 90, 69, 70 pages. This is 61 pages. This is 46 pages. This is 37 pages. So, yeah, generally it will be, we can take average as 64. I'll take around with our current workers. Uh, yeah, keep it. I don't want to increase this. So, I'm estimating it'll take 2.5 days. But by tomorrow, this time, we should have around 3,000 documents already processed. And yeah, then I can start the live stream with whatever the documents we already have at the current moment. So let it we just start on work on the agent, because even 1,000 2,000 docs is more than enough for us to sort of try and see how it sort of responds and etc. And then yeah, we can slowly, not slowly, we can just keep on developing, and we have domain acronyms to solve and all of those stuff. So let us start on that. Let us start on domain acronyms tomorrow. That'll take a decent chunk of time, definitely. And then Tuesday we'll have everything. Thursday we'll wrap everything up, and Friday the project should be live. Right, that's the plan. Hopefully, should work. So I'm okay even if it takes 3 days. I've got time. I've got some time anyway. So 3 days should be fine. So 51 hours with this 62 hours. I actually think, for example, over here, this particular image we tested one of the worst scenario over here of processing this much at a given time. Usually you don't have 300 images in a given PDF. So the per page sort of check-in should definitely be around 200. We should be ranging around 200. I'll control B. I'll run this in the background. It's fine, we can check back later. But I'm just curious. Our last test was with how many workers? I guess 8. I guess 8. Yeah, 8. Embedding batch 512 implement. 10 Dockling instances, another 9 minutes per block. Okay. Okay. All right. Until it loads, I think we can start the processing right now. We can start the process right now. I would probably definitely wanna, or actually no. Actually, we'll keep this as default. And what else do we have to complete in phase 4? Oops! Oh shit! What happened? Wait, I'm not sure what happened to the background task. Failure corrupted 11 total pages. Oh god, 671,000 pages. Completed. Yeah, it'll take 2.66 days, meaning 3 days. 62 hours. So you're looking at 2.5 days at the current rate of 8 workers. So close to 2 days if you can push to 10 to 12 workers. Let's actually try 10 workers and see. We did try 10 workers before. We didn't have a huge impact. Nothing worked out well for 10 workers, but we'll try. We'll just give it a shot and see. It is. Run concurrency yet. Flash. Then okay, so you should start. You should see all the bump here. It's 95. Oh shit. Oh, very close. Very close from being. Okay, yeah. We broke it. Yeah. Sure. But still, I don't think it should have any impact. I think it'll eventually come down, and then we continue. I think we continue. Oh yeah, he quit. Yeah. No, no. With this. See, this is the issue we don't want. Like, we don't want any issues in the middle. So, I think this is 8 with a buffer of 5 to 6 GB is the sweet spot. I think, yeah, I don't want anything to fail in between, and I don't want to spend time continuing from there now. Just pure waste of time. Just 70% allocation, and then we keep at the same rate, but workers has 8. Yeah, we'll stick to the same 8. I think we'll take around 2 days, 2.5 days. Yeah. Maybe 60 hours totally. All right. Yeah, sweet spot. Update the document with this. I think we're good to go. I also want you to check what other items are left in phase 4. I think good to go, guys. Whew, pretty challenging for 4 days, I think. And yeah, and actually, this is very good. Without when we started off, we aim for 28 days. Yeah, literally 28, 29 days something. And right now, that was the worst case scenario. And then we did the entire re-architecture. We changed up the GPU count. We changed up the CPU layers. We removed PyPDF. We dissected most. We basically removed all of the inefficient parts and put it into one layer for sequential processing extra. We did a bunch of things. And now we're down from 29 days to only 2.5 days. So yeah, around 66, yeah, 66% reduction in time. No, I think no, 60%. No, I'm bad at math, but yeah. Yeah, we just 10%, yeah, 90% reduction in time. Yeah. And still, if we had more and also very scalable as well, very scalable option. If you were to inject another GPU, let's say H100, then this will double. For example, from 2.5 days, it will come down to 1 day. No, maybe even less, like 19 hours, 21 hours, or something like that. And if you have like a B100, B200, then this is nothing for you. Like you can easily process all of the stuff at this scale, um, in like I don't know, B200, you have the 150, yeah, probably like, yeah, 15 hours or so. Still fast, and that has more memory and stuff. You can still load so much of stuff and make it fast. And yeah, so and also you should note we're using the 7B version, but also FP8 version. You can go down to int 8 if you want. It'll take a little bit more, less RAM. And if you want, you can also go to Concurrency 4 version. That's the last of all. You don't want to go. I mean, I don't want to go to 4 because you'll have a lot of inaccuracies. And I also use FP8 because H100 natively supports, and that's one of the reasons hoppers were built. So that's what we went with it. But if you are still, having a lot of memory crunch, it's about timing only. You just keep it running for a couple of hours, days, whatever, and then get it back. And timing, or in terms of memory, if you want to do this stuff, and if you only have very very low amount of documents, then not low amount of documents, but low compute, you can still stretch the models. You can squeeze a lot of things. You can reduce the number of workers, or maybe even you can. What do you call if you have more compute, then you can fire up a 32 billion parameter model. If you have, I don't know, if you're a startup that's you have a lot of million, you probably have a lot of compute, let's say access to a lot of GPUs and etc., then you can even bring in a 120B version, or maybe like a 225 billion version, and etc., to bump up your accuracy. It's at the end of the day, it's your needs. At the end of the day, it's something that you have to architect and sort of come to a conclusion on. So yeah, not now, but later what we'll do is that I'll have like a test or something like that, which scans your CPU, GPU, all of those stuff, and then gives you, what could be your sweet spot number, just a bit normal prediction sort of thing. Okay. And let it process. 94% is less, and you have like a quick gap over the production. Okay. There's only 11 corrupted files, but I assume at least 10% will fail. Like easily 10% of the files may fail. Okay. I want to quickly try with 7 workers and see. I'll quickly try here. Start this. Starting. Okay, it's the doctrine. What's happening? And here, I think yeah, I also want to check one thing here, like rerunning failed docs. For example, let's say we run, only concurrent, we run about 8, right? So, how would the rerun work? Let's say in an 8, one fails. When would it retry and all of this? Because I don't want it to bring unwanted congestion to the GPU. And also, if a document is probably failed, it's only because it's corrupted. We usually know that. And I mean, we can accept a little bit of failure rates. I don't wanna, I don't want any surprises. That's what I think. Maybe we can have, collect all the failed without retrying the failed ones. We can collect all the failed ones. We process everything, and then later, we have access to the failed documents, right? Then we can actually reprocess them manually when needed. This means that there's no GPU congestion, no surprises, no breaks, no new requests and etc. We have the buffer there, and all should be fine, and there should be any lags in the between. Additional to this, I also, of course I wanna quit the VM, but of course I don't want all the process to be I don't want the process to quit, right? I want all of the process to actually run, and I want them to keep on running. Whenever I want to jump into the VM, check the progress, and then go back, I'll quit the VM, but I want it to be running. Maybe we use screen for this, or maybe Tmux for this, right? Tmux for this. um yeah. uh yeah, what are your thoughts? Quick note and note. Also another note I want to note. Clear- clear collection fails for box two. Where again, chance. Yeah, but we want to note down the failures, like where did the failures go on, etc. Yeah, collect for manual review. Yeah. Yeah. With a new session, concurrent table, create new workgroup, monitor the progress, create new window. Okay, cool. I think this might still be less than 180. I think the best is 8. It is the best. Maybe the sweet spot you can say. Yeah. There's no best. I mean, if you were to try, a couple of times, 7 workers might still end up with something a very decent number, but you would never know. So just to be on the safe side, we'll stick with 8. I think it's like a. I think it's fine. It's a decent number to wait. So current stored. Okay, 2 failed this time. Okay, because the memory hits. I would say we'll stick with this. Sure, but also I also sure now when I start dockling, I only want to start um 8 dockling services, and I think in our previous code we also brought in another 2 like 9 and 10. I don't want that. Just remove that. I only want 8 maximum. Okay, 2 are gone. I want to try flush everything and try it one more time. 8 starter. Okay, let's watch this. Okay, maybe I can run 9, just one more. We try 9 because we got rid of like 2 GB. We saved about 2 GB from that. We can use this here. I'll try 9 and see. Okay, done. So same average 180.6. Even last time 180 point something. Yeah, the average is 180 with 8. But you can see we have 83, 95, 12 gigs left. If we have a bump, but I want to try one more time before maybe everything is set, right? We just have to, run it on a screen and just quit VLM and then wait. That's it. Uh, but I want to just try with a concurrency of 9 just to see in case a little bit, even 10, if you can use that 2 or 3, whatever is available, just a little bit, that'll be definitely be useful. So I'm going to go ahead, reflush this, just last test, and then we're done. Okay, 180 is the last one. We run this, add something here. Right. No, actually, we don't have. I want to quickly try for 9 workers, so just enable 18009 quickly. And I just want to try it and see even if I get like 5 or 10 bumps. Yeah, still useful, but it can plateau as well. So just add it. I'm adding it manually, so you can add. You should be able to see one added manually. 1, 2, 3, 4, 5, 6, 7, 8. Ninth one will work when we actually run the request, I think. So yeah, we'll wait. So at 9, I should load all the doc. Yeah. Just now we'll stop everything. There's some small crash. We'll flush all. And wait for a couple of seconds and then hit. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, and 8. 1, 2, 3, 4, 5, 6, 7. Only 8. You should also update the docklink start command. Okay, there's 9 now, 4 here, 4 here, and then the fifth one. It'll take around 4 minutes. We can do something else in that time. Install this if needed. You should install this. CD source. Wait. We'll install this. Tmux create new session with Meridian, and then inside you run this concurrency 8 or 9, whatever, and then watch it. Summary of changes, max choice, documents. Okay. Yeah, afterwards, job is simple. You still have to wait and see. Also, it's like whenever you work on this stuff, have an expectation that things might fail in between. No, it can happen. You don't know any reason, and you would only know why it failed in the first place. So that's one of the reasons I wanted to finish this quick and start the process, because I know it'll take a couple of days, and it gives me a lot of time for me, and gives me a plenty amount of time for me to debug this parallelly as well. But right now I don't have any. I can't afford to lose any time, so that's what I'm doing with this 10 GB of 10, or like 10. How much? 10? Yeah, 10 11 GB with buffer. But if I had time, if I can afford to retry whenever I want, and then spend a little bit more time in it, what I would do is that I would actually get it, just take another 5 to 6 GB risk, increase the model's utilization a little bit, just try to find a little bit of just try to find a sweet spot among 9 or 10 workers or whatever, and then increase the batch size and then put it. So you'll only have, the model will go close, like very close to hitting the GPU memory, and then it will stop. And then it will go very close and stop, very close and stop. You can also set it dynamically. Let's say the model is already, very much close. Then what you can do is that quickly pause any request, or take a step back with any other request if you want to. Stop all the passes if you want to, dynamically change it. But that's a different work. That's a different level of infra, and it's not a problem for us because we have a lot of things on our plate to work on. So, yeah. But you can try. That's what I'm saying. What I'm saying is that you can try it. You can definitely try, because you might find efficiencies, because see, we only have 95 GPU, 95 GPU of GPU, right? And even that 10% of that, extra 10 GB will have a huge boost. Instead of 180 pages per second, you can do 210, maybe 20 30 pages, sorry, a minute, 20 30 pages a minute advance. If you were to compare that to, if you check, that's I don't know, that efficiency gain with 20 30 docs, with that's about 20% gain, 20 30%, yeah, 20%, yeah, 20% gain. Yeah, if that's the case, you'll easily, instead of 2.5 days, it'll be 2 days, like 7 8 hours of time being saved. That's one number you can look at. You can also do so many different things. For example, what you can do is, instead of processing, we have 5 GB of embeddings, right? I mean, of course, I'm deprived of, or you can call it, I'm limited on the compute available. A lot of the guys, you guys probably working on startups, you will get very good or decent amount of compute available. And plus, my Azure subscription is also converted to pay to go, because I've used all the 40,000 tokens. So I have $40,000 of credit available to me. So after this, I'll probably wrap it out. But yeah, you get the idea. When you have more RAM, you can definitely tune and use it. Plus, also try to find a sweet spot that will actually give you access to the future errors. And for this, I'm just confident that I won't have any errors, because we've tested most of the time. This is exactly how the other batch will run. For example, if you see 9 concurrent docs, we see 9 concurrent stuff, right? When it goes to the other batch, let's say, I don't know, 25 30 whatever, 40 docs, and then 9,000 3,000, you'll have the same criteria or the same distribution of RAM, because we're clearing out RAM whenever it's time, it needs to be. So we clear all the RAM out, and you have like a clear stage, and you can see right now it's all cleared. It's all in 1200. Everything is very 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 much the same. So yeah, here I will not expect, I don't want this to fail. But yeah, in real world scenario, if you want to sort of get that little bit extra boost, you should definitely be a little bit open to fail, have retry mechanisms, to pause or whatever. Currently we actually have retry mechanisms over there. What I'm doing is that I'm saving all the failed documents. A few, I would say 10% might fail, and then I will run another retry for only the failed documents. Yeah, apart from that, I guess, yeah, that's sort of it. We're in good shape. The final two documents left. Yeah, I forgot. I was talking about something else. I was talking about the embeddings. For example, you see 5 GPU embeddings, right? What I can do is that just to increase, maybe I'm not sure if I'll do it, but one possibility is to if you 5G, you have 5 GB, right? Just save this and save the chunks in JSON or something like that, and then at the end, once all the documents are processed, you'll only have 5 GB extra, not a big difference. But then later you can actually compute the embeddings and store it. That's one option. Still not a couple of hours of save. Like let's say you spend 2 days, it's like 2.2 days sort of thing. So not a big difference. You're still looking at days. Days sort of different. That wouldn't make a big difference. If you have one extra GPU, then you can basically manipulate dates. Like you add, like for this exact system, you were to add another two H100s. This will be completed in 7 hours or so, 6 7 hours or so. Yeah, 9 is blocking. I think it's tightly blocking it a little bit. So and actually three documents have failed. Why is it disconnected? I think you should put the retry back because I can see we have three failures. Usually it's only two failures, right? Or one failure. We have three failures and it didn't retry. I think maybe you should just get the retry code back. Just retry once more. If it doesn't, I guess yeah. Before the original code was that we try it one more time. If not, we just don't retry it. Save it as purely failed or something. Yeah, because this is okay, but this is a different error. See this? I think we should bring back the retry. Oops. Okay, we have to kill this. Wait, I think we'll stick with 8. 8 is the number, I think. Okay. And also revoke the code we did with 9 workers. We are sticking to 8 because I don't see any huge difference. You can see over here. 8 minutes 54 seconds. That's the page stamp, but still 167. It's not a big difference. Mm, you know what? Actually, I want to test it and see. No, we'll actually test it one more time and see. Flush all. We have concurrency. Test it. four. There's only 4 workers. I can only see 4. Yeah, before. Stop and retry. Flash. Yeah, this is no reconnection issues, none. Watch. A second. Oh, it'll crash. Yeah, it crashed. Okay. Yeah, 9 won't work out, guys. 9 won't work out. Yeah, please revoke the code. And sorry for interrupting. You will revoke the code back to only 8 workers. We'll be sticking with 8. Sure. Okay. Okay. Nice. Alright, guys. Uh, Okay, we'll try one more try just to verify everything is working, and then we will start. Just call it fixie. Start on the okay. Yeah, all of this is coming from the VLM. Yeah, let it run. Just come a bit. Mm, range is low. No, no, same range, same range. Push. Chunks. Okay. Yeah, that we just oops. Oh my God. Wait, wait. I'm gonna go in. I actually think this will be a little bit slow. No errors, by the way. Only this is corrupted document error. Otherwise, a retry. This is averaging at 166 pages per minute. Should have been 180, but it's okay. Let's finally come back and see. I can see it's 8 workers. 8 only, I think. Yeah, 8 workers is the original assumption. And you have this. Yeah. Yeah, doesn't matter. Still, it will change. Very much change. Be very, here and there. Because right now you have we working with sort of PowerPoint sort of PDF. That's what taking a lot of time. But usually, it should range about I think 200. Average usually documents like average is low. Average is usually low. But if you think about pages, it will definitely be high. So it's 155. Could have been more actually. Oh, no, it's actually good. You completed 183 pages per minute, which is very good. Cool, cool. A math never fails. All right, let's start. All right, actually start the process. I think 5,000, 5,158. All right, so I'm gonna start Tmux. Before that, should I? Is there any quadrant limit, or in case something goes wrong? Let's say we process 3,000 files and we fail in the middle, GPU crash or whatever is going on. Would we can we come back and continue from the file we left on? Like if we fail on 3001, can we continue from 3001 to the rest? The answer is yes, but just to confirm, in case I miss something, create a new session called Meridian. Okay, so we actually come back. We go source bnv bin activate and bnv. Now go to the search. Yep. Because the path is different, so we have to fire it off with a new file. And I know for some reason you can see VLM is actually having some cached in data as well. It's hovering around 67 GB, 68 GB. Before it was different. But it's okay. Okay. Production will start this concurrent 8. In case it fails, okay. Worst case it will fail. We'll come back and fix it. It's okay. Let's try that. Okay. Cool. Then like watch and oh, 3 is already complete. This will work. If I have to detach from this, 93 pages a minute. Okay, let it go. And yeah, I'm gonna quit the stream, but I think we've started the processing of 10,000 documents. Yeah, hectic few days, but figured it out. Yeah, let it run. I'm also going out, but this is running on a Tmux, so even though if I quit, there shouldn't be any issues. I just have to detach from it properly. Where is it? Detach. Okay, control B. Okay, control B. Okay, let's see it. Control B and C. Detach. Control B and D. B. Okay, detached. If I want, I can attach to it. We'll actually try it one more time and flush everything because I did something stupid, I think. Kill the server also. Control P, Control P. Semi developers, concurrency 8. It's ready, and here I will just run this production and I'll call it production real. Okay. Yeah. It should start. I'm sorry. Oops. Connection refused. Connection refused. Why? You know what? We have to kill this. Exit. Okay. I knew. Just a minute. Yeah, 2 minutes. Can you wait for 2 minutes? So session, new session. We'll get this right this time. What else do you need here? You need to start all the services. Okay. Starting all the services 808. Awesome. And record production final. Conclude. It started. Production final. Let's go for it. All right. Started everything. There we go. And here. And we can watch the progress if we want to. We will, quickly Control P and D detach. Cool. And this. Okay, yeah, so it's running with a 10 GB of around 5 to 7 GB of buffer, GPU buffer. And here you'll have the quadrant being saved. Where is it? It's called production final. Okay, and all the chunks are being saved over here. All right. All right, so we actually 0.1 already done. So cool. We'll leave it for a couple of days and we'll have this ready. We've somewhat done some decent work, I would say. And yeah, catch you guys in the next stream. And yeah, we'll see. We'll talk soon. Tomorrow we're gonna work on domain terminologies and we're gonna grab 4,000 to 3,000 domain terminologies and build a RAG across that to be able to for the agent to properly query and stuff. But yeah, hopefully we'll figure it out. All right, awesome guys, thank you so much. It was a very challenging couple of days, 3-4 days. I bashed my head through the wall. But yeah, finally we have this. Yeah. Yeah. Thank you so much, guys. Talk soon. Bye.